Alright, so now we're going into 2.2. Got a quick warm up here, so make sure that you pause the video and go through it and then check your answers. I'll give you a second to do that before we get started. Okay, so the questions here in the warm up again, you notice they're saying determine if each statement is true or false. So in order to show if something is false, we've got to see, can we find a counterexample to it? And then at the same time, do we know the definitions that match the definition that we already know? So there's a couple things we can do to kind of determine these. So number one, it says the measure of an obtuse angle is less than 90 degrees. Now this is just based off of definitions. Obtuse means greater than 90 degrees. So because you know the definitions, you know that this is false. So number one should be false. Number two, all perfect square numbers are positive. And again, you have to look at the fact that if you try to take the square root of like a negative number, you have to ask yourself, what times itself equals -4? Well, nothing times itself equals -4. So this would, number two, would also be false. Actually, sorry, all perfect square numbers are positive, so it is actually true because we can't come up with a counterexample. So number two would be true. By the way, if you were wondering, what do you do if this ever happens? You probably weren't wondering, but I'll tell you anyway. If you have a negative number, there's a thing in algebra, actually, it's called an imaginary number. So you think of it like this. Oops. I know how to write, I really do. There we go. Okay. And what you would do is you'd say, well, the square root of -1, it's actually not a real number. What we do is we call it I, it's imaginary. So this would be I, square root of 4 is 2, so you'd call this 2I if you had a situation such as that, just so you know. We'll talk about it later in you'll see it later in Algebra 2. But anyway, number two is true. All perfect square numbers are positive. If they're negative, you get I. Number three, every prime number is odd. Well, if you kind of start listing them, you would start right off the bat with 2. Now, after that, they're all odd. But we have a counterexample. By the way, it's 9 is this, not prime. If it'll erase, there we go. So the next one after 7 would be 11. But again, we have a counterexample here. There's our counterexample. So this is going to be false. Again, if you can find one scenario where it's not true, well, it's a false statement. Next up, any 3 points are coplanar. So in this one, again, I talked about this in the last lesson. If you have 3 points that lie on a line, those are called collinear. They are technically coplanar in the sense that they do lie on the same plane. You just couldn't label a plane using those 3 points, because to label a plane you need to have 3 points that are non-collinear. But the way this is stated, it just says any three points are coplanar. Coplanar means 3 points that lie on the same plane. So I can label any 3 points that I want, whether they're collinear or not, and they're going to lie on the same plane. Again, only this one right here, you would be able to use these points to label the plane. I couldn't do that here. Yet they are still coplanar though. If you think about the actual definition, this would be a true statement. So 4 is true. Alright, so there's your warm-up. Let's get into conditional statements. Alright, so the goal today is we're going to need to learn how to identify, write, and analyze the truth value. So we're going to need to know what that means when we're going over lessons today. So we're going to have to learn about truth value. So make sure you write that down and understand what it means. Make a note of this, of conditional statements. Now we'll talk about the actual definition later. Write the inverse, the converse, and the contrapositive. You're going to want to definitely know what those are. So we're going to need to write those. The contrapositive, I'll just do one here. of a conditional statement. So these are all the things we need to learn about, all the things that I highlighted. We're going to learn about them, but you need to know what we're trying to focus on. So these are all the words that you need to make sure you know. Okay, so to get started here, we have some of our basic statements about conditional statements. So we have a conditional statement, again, is a statement that can be written in the form if P, then Q. So if this thing happens, then I can say that this next thing will happen. There are two parts to that statement. You have the hypothesis, which is the first part. So that's your hypothesis. And then that's when you say if the following happens. So if the sun comes out, then I will wake up. That could be a potential conditional statement. The if the sun comes up is the hypothesis. The conclusion is the thing that happens as a result of the hypothesis. That would be I wake up. So this would be the conclusion. Here, let's call it Q. And these are typically the variables or letters that we use to represent hypothesis and conclusion. They can be different letters, but it's just like in algebra how X is your most common variable. Well, in a logic statement, P is typically the hypothesis and Q is typically the conclusion, although it can be other letters. Okay. So again, the statement down here, by phrasing a conjecture as an if-then statement, you can quickly identify its hypothesis and its conclusion. That's really what we need to be able to define in this unit. Okay. You definitely need to know about these. These are basically what we're doing this whole unit. And you'll see this in a lot of our proofs as well. We're using conditional statements all over the place. Again, conditional statements, just so you know, I'll put this one last thing up here. Sometimes they're just called if-then statements. So you'll see them kind of talked about in both ways, an if-then statement or a conditional statement. Okay, so again, to get started here, we just have to be able to recognize the different parts, the hypothesis and the conclusion. Okay, so in this case, that's all we're asking you to do. So identify the hypothesis and the conclusion of each conditional statement, of each if-then statement. Now, it's pretty simple. However, there's an important part to this. We need to understand that the hypothesis is not the if, it is the statement after it. So, in this problem, if today is Thanksgiving Day, well, if we list this is going to be your hypothesis. And then again, notice what I highlighted. Today is Thanksgiving Day. So there's your hypothesis. The conclusion is not the then. It is today is Thursday. So we got your hypothesis and we got your conclusion. Kind of, it's both. It's that whole statement. Again, the hypothesis, and I'll put this in here, does not include if, and the conclusion does not include then. Okay, I just want to make that note because a lot of people will make that mistake. Okay. Now in this case, notice you'll have in example B, it says a number is a rational number if it is an integer. Well, in this case, what we need to do is we need to restate this so that it is an if-then statement, because right now it's not. So you have to say if, and we need to reword this. Okay, if a number. So again, we got our if here, so we can kind of start with that. Now what they did is they kind of flipped this whole thing around. So you got to be able to rewrite it. So it starts with the if and then goes to the then. So I'm writing it in terms of an if-then statement or a conditional statement. So if a number is an integer, then it is rational. So again, in this case, we just had to rewrite it so that it became an if-then statement. Once I do that, I can highlight my hypothesis, and then I can highlight my conclusion. So again, writing this down, we have our hypothesis and we got our conclusion. So if a statement is not written in if-then form, well, we need to write it in that form so that we can find, again, that hypothesis and that conclusion. Now, if you're writing this out, I'll just put this off to the side as another note. If you're writing it out, you could write it like this. Hypothesis, in this case, is a number is an integer. If you're just writing the conclusion by itself, it wouldn't make a lot of sense because you'd say it is rational. You could write it like this. The number is rational. So again, that's acceptable when you're writing a conclusion, because if you just write it is rational, it's kind of like, well, what are we talking about? This way it's not ambiguous with the pronoun. A little bit of English for you. You can't start a sentence here with it if you don't describe what it is. So you can say the number instead. Okay, a little bit of just standard English there. All right, so example 1. Again, we're doing the same thing, so you can kind of continue with what we were doing before. Identify the hypothesis and conclusion of the statement. So this is just like the one we just did. If you want to go ahead and try it, you can. You just need to make sure, again, you need to write it as an if-then statement. Again, you can pause before I get to it, and you can give it a shot. All right, but what I'll do is I'm going to go if, then. Technically, then is within the sentence, so I'll do that. Okay, so again, a number is divisible by 3 if it's divisible by 6. So see here, I got my if, so that's where I'm going to start my sentence off. We don't want to say it to start the sentence, though, so we need to reword it. So if a number is divisible by 6, then I can now say it is divisible by 3. So again, in this case, you're going to have your hypothesis. A number is divisible by 6. You're going to have your conclusion. It is divisible by 3. So again, you got your hypothesis. You got your conclusion. Again, if you're writing the conclusion, you could say the number is divisible by 3. If you want to get rid of the it, if you're writing it out. If you're doing it like I'm doing it, it's within the sentence, so you kind of know what it is. It is the number because you saw the earlier part of the sentence. Okay? Alright, so next up we're going to go into the different type of symbol notation. We didn't really talk about P and Q yet. So here we go. If P, then Q is our statements, our conditional statements. Again, P is the hypothesis, Q is the conclusion. Okay, so a couple ways you can write it. Again, you got if P, comma Q, Q if P, P implies Q, P only if Q. There's all these different ways we can write. We're going to go over these as we go through some examples. But remember, as you do these, P is your hypothesis, Q is the conclusion. Now again, I like to get it in this form unless we're dealing with a biconditional, which we'll get to when we get to it. Don't worry about that yet. Okay, but that's kind of where we're heading now. So here we're going to write a conditional statement from the following. An obtuse triangle has exactly one obtuse angle. Now, what we're doing by this is what I've already done. We've already talked about this before. I'm trying to get it, though. I'm going to talk about that symbol notation. I want to get it into this form. When I say write a conditional statement, so I want to write as an if-then statement. Remember what this means. It means if P, then Q. Again, we've already done this before. We just aren't going to identify hypothesis conclusion. But in a way, even though when we do it this way, we are identifying the hypothesis conclusion, because I got to know what to put in for P and what to put in for Q. Notice how if is not part of the hypothesis, right? It's if hypothesis, then conclusion. Again, I stated that earlier as well. Now this one doesn't have the if to help you out, right? So you have to just rewrite it in that form by just using general logic. What would come first? What would come second? So again, we have an obtuse triangle, has exactly one obtuse angle. So here we go, and I'll give myself some space. I know I'm going to have an if then, okay, but I need to first clear that so I make sure I have enough room. So this one, if you look, we're going to have an obtuse triangle is what we get out of this. Oops, kind of messing that up. So that's what we're going to get out of it, and not that crazy figure. So this is going to end up being our conclusion. If you take a look at the statement, that's the output. We end up with an obtuse triangle. So if I rewrote this, I would say if a triangle has exactly one obtuse angle, then I don't have to say the triangle again because it's the same sentence, so I can say it is an obtuse triangle. So again, in this scenario, your answers may vary on how you write it, but you have to still realize what are you starting with and what are you ending with. I'm starting with the statement that I have exactly one obtuse angle. I'm ending that with the statement that I can now say I have an obtuse triangle. So you got to know where you're starting, where you're ending. That's the key. Now how you write it, it can vary slightly, but it shouldn't vary a lot. Alright, so this one we're going to have write a conditional statement from the following. I didn't really talk about this too much in the previous slide, so I'm going to hop back to it so you can see it. I got to find the slide. Where'd it go? There we go. So if you look here, what you have is you're going to have your hypothesis is, if you look at it as a Venn diagram, this is if the sun comes up, or some of the other statements that we had, but this is your hypothesis. Now from that you're going to get a conclusion. Now this conclusion only occurs if this thing occurs. So that's why this is going to be within the conclusion. Maybe there's some other things that make you wake up. Okay, maybe loud noises make you wake up. Maybe your alarm going off in the middle of the night makes you wake up. There are a lot of other things that could happen, but again, this hypothesis is within this conclusion. So if we look at this example, this will be P, this will be Q. Okay, so we need to write a conditional statement from that statement. So we're going to have our if, and then we'll have our then. So I'll write it like this: the first half of the sentence here, then the second half there. Okay. So if we have blue jays, now again, this is a type of bird, then we'll have a bird. So you got to figure out a good way to actually write that. So in this case, we can say if an animal is a blue jay, then it is a bird. You'd be kind of redundant if you made the statement, if a bird is a blue jay, then it is a bird, because you're already kind of putting the conclusion in the hypothesis. So we have to say something such as animal. Okay, if an animal is a blue jay, then we can then conclude so that animal happens to be a bird. All right. So again, just a couple of different ways you can look at a statement and make it into a conditional statement. All right, next up, two angles that are complementary are acute. So we got to look at what comes first, what comes second. So again, we are going to have our if, and we're going to have our then. And again, let's look at this and say what's coming first. So we got two angles that are complementary. What are they? They're acute. So this one, even though it's not written in if-then form, it is written in order because the angles come first. Once you have the angles that are complementary, you can then say that they're acute. That's your conclusion. So you need to write that in that if-then form. So you come down here and say if two angles are complementary, then they are acute. And by the way, all these statements we're going over are true statements. I mean, if you think complementary means they're 90 degrees, so acute is less than 90. So unless an angle is 0, which we wouldn't even consider it an angle, it's going to be less than 90, okay, if you're adding two of them up. So these are true statements if you're wondering on any of these statements we're going over, okay. So again, we'll keep writing these no matter what form we're in. You got to see what came first, what comes second, so you know what the hypothesis is and what the conclusion is. Alright, so now that we know how to write those statements, no matter what form they're in, we can still get them into a biconditional form. Next, we'd have to be able to figure out the truth value, which means are they true or are they false? The ones I said we are doing so far are all true. That doesn't mean all the ones we'll do in the future will be true. We have to figure that out. So again, the truth value is if it's true or false. It is false when the hypothesis is true and the conclusion is false. To show that, again, I'm just reading through this, to show that a conditional statement is false, we need, just like we did in the last unit, you need to find only one counterexample where the hypothesis is true and the conclusion doesn't hold true. For example, the statement I said earlier, if the sun rises, then I wake up. Okay, you may come up with an example. Maybe one time, you were really sick. The sun rise, you didn't wake up because you were really sick. That's easy to come up with counterexamples because there's probably many days where you were still sleeping when the sun came up. Okay, so that would be a false statement. Doesn't mean it's not a conditional statement. It's just it's a false one. And so the ones we did after that, all the examples we did, those were all true statements. So anyway, let's go and try some truth values. Okay, so in this case, we want to analyze the truth value. So determine if the conditional statement is true. If false, tell me why. Just like if you were in an argument with somebody, and the first thing that they're going to do if you're arguing is you say, well, I'm right and you're wrong. They'll say, okay, well, give me an example. That's the first thing they're going to want. They want you to prove that you're right by showing an example. Or if you're trying to say that they're wrong, is really what we're trying to do here. Say, well, if I'm wrong, tell me when I'd be wrong. Okay, well, that's what we're doing here. Okay, if this is true, it's true, but if it's wrong, we have to say why. Don't just say false. So if this month is August, then, so again, we got our hypothesis, this month is August, then our conclusion, next month is September. Well, this one, if you know your months, you know is true. There's nothing to argue with here, because if this month is August, then next month, yeah, it will be September, because that's the next month. So that one's going to be true. Next up, if two angles are acute, then they are congruent. Now this one, hopefully you can see that it is false. But again, you don't just say false, you have to give a counterexample. So if two angles are acute, then they are congruent. I can just give you two angles right now that are acute. They have to be less than 90, so I can say 80 degrees. And I'll say 40 degrees. There's your counterexample. Your answers may vary, but there's one. You don't have to write my example. It's pretty easy to prove that one false. Okay. Alright, next up we have the statement, if an even number greater than 2 is prime, then 5 plus 4 must equal 8. Now this one's kind of screwy. If you look here, we have the two parts to this problem. We have an even number for your hypothesis. It's greater than 2 is prime. Well, if you look at that statement, the statement's not exactly true. And then you get this next statement. And this statement, what? This isn't true either. Because like I say, you look at this, we got a false statement here. We got a false statement here. Now, in terms of logic, two wrongs do make a right. In this case, if you're talking about the truth value, this one we're going to actually call true. Now, not that the statement itself is true, But again, what we're going to talk about here as we move forward is, again, if an hypothesis is false, the conditional statement is true, regardless of the truth value of the conclusion. So you can't make a valid conclusion regardless of what it says if the hypothesis isn't true. So because we can't necessarily, you can say, conclude anything from it because the hypothesis was wrong to begin with, we have to give it a truth value of something. So we're going to just say it's true based off of the fact that we can't really prove it otherwise or in any way, shape, or form. So that's kind of tricky here, but because I can't even really get to this statement because this wasn't true to begin with. So again, because of that, these are going to be considered true statements, even though you can't really show what they are in general. Because like I said, if the hypothesis isn't true, I can't even really get to this, right? So I know it's kind of a tricky little thing here, but again, this one actually is going to be true. Alright, next up, determine if the conditional, if a number is odd, then is divisible by 3 is true. If false, give a counterexample. Same thing we're doing, right? So if a number is odd, so we can come up with some odd numbers. 3, 5, 7, 9. Then it is divisible by 3. So divide by 3, that's 1. Here you divide by 3, and that's 3. However, you divide that by 3, well, you get 5/3. You divide that by 3, well, you get 7/3. So it's not really divisible by 3. So again, if a number is odd, then is divisible by 3 is not going to be a true statement. So therefore, you can say it is a false statement. You only need one counterexample. I have 2 of them there. And there are many other counterexamples actually. I just one quick example of one. Okay. So again, for the most part, these are pretty easy to spot, I would hope. If you know how to find counterexamples, you can fly through these pretty quick. It's all logic, it's not a lot of actual math, I should say, that what you're used to. Okay, so next again, we've got the hypothesis false. The conditional statement is true, regardless of the truth value of the conclusion. So when we're doing our truth values, like the one we did earlier, okay, we had a false statement at the beginning, we had a false statement at the end. Again, that whole statement is kind of messed up in a way, right? But again, if the hypothesis is false, the conditional statement itself is true, regardless of the truth value of the conclusion. So again, that's why we had that one earlier as a true conditional statement, right? So again, this is just a reminder. I went over it already, but just kind of giving that reminder one more time. Now, getting into that a little bit more, we got negations if things are not true, okay? Or sorry, the opposite of the statement is going to be considered a negation of that statement. So more just, again, logic rules here for you. So again, if we have the phrase P, not P would be the negation of that statement. It's going to be written like this. Again, you'll see examples in a second, so we got to get this down first, and we'll look at the examples. The negation of a true statement is false, and the negation of a false statement would be true. Okay, so again, make note of that. If you had a true statement and you do the negation of it, it's false. If you have a false statement and you do the negation of that, then it's now going to be a true statement. Alright, so let's go try these out. Oh, by the way, I already did kind of write this already, so you saw that P arrow Q. So this is just a reminder again of a conditional statement. This means if P then Q. Okay, I already talked about that though, so I'll keep moving. Next up, and we got our converse. So what you should do on these next few slides, I'm going to go over them right now. Actually, before we kind of get into this, you have your original statement, if P then Q. Now from here, you need to write the following. You're going to now have your converse of that statement. Well, the converse is the opposite of that statement. Okay, so these are common phrases used in any type of logical thinking. Now that we finally talked about this, I use this phrase a lot, the phrase conversely. If I'm making a statement and then I want to say the opposite of that statement, I'll use the phrase conversely, such as, let's say, when I work hard, I see results. Conversely, if you see results, you probably worked hard. And that's, again, that's a logical statement, and it's also some vocabulary you need to know. All right, next up, we're going to have the inverse of a statement. So you have if P then Q is your original. Well, if not P, then not Q would be your inverse. And the final one is going to be the contrapositive. And that is the converse and the inverse combined. So this would be if not Q, then not P. So notice you're combining the converse where you flip them and the inverse where you negate them. And that's what these next few slides are all about, making sure you know all those different types of statements. So you'll see that here, talking about inverse, here, talking about contrapositive. Okay, so in this next one we have some science facts here. We're going to write a converse, an inverse, and a contrapositive of the conditional statement. We're going to use the science fact listed below to find the truth value of each one of those statements. So we need to write the following. We're going to need to write an if then, if P then Q. Okay, we're going to start there. So what we need to do in this case is we need to write our first statement, and it's going to be just good old if, and then we'll have our then. So here we go. If let's say something like this. If an animal is an adult insect, something like that. If an animal is an adult insect, then it has 6 legs. So there's our if-then statement. Again, there's a few variations you can make from this, but this is the one we came up with. And once you came up with this statement, you got to figure out is it true or false. So if an animal is an adult insect, then it has 6 legs. So we got to see, looking at the statement that we have here, no other animals have 6 legs. Can we figure out if that's true or not? Well, if you look at this, no other animals have 6 legs. So you're really looking at the fact that if an animal is an adult insect, it must have 6 legs. Well, there are a lot of animals that don't have 6 legs, so that would be a false statement, this original. So this original conditional is false. But that doesn't mean all the other statements are going to be false. Let's start with the converse. So the converse, again, is going to be if Q, then P. So if I wrote the converse out, I'd say if an animal has 6 legs, then it is an adult insect. So if you look at the statements here, adult insects, they have 6 legs. So an animal has 6 legs. It must be an adult, because that's what the statement says, or a science fact. So this would be a true statement. So there's our converse, and it happens to be true. So again, just because a statement is false doesn't mean its converse is false. Next up we have our inverse. And that's, again, if not P, then not Q. So I wrote that statement. So now we're going back to our original. If an animal in this case is not. Look at my original statement. My original hypothesis says if an animal is an adult insect, I need to say the opposite the negation of the hypothesis. So that would be if an animal is not an adult insect, then I'm saying the opposite now of the conclusion. Instead of it has 6 legs, then it does not have 6 legs. So in this case, again, just because the original was false doesn't mean this one's going to be false. Again, an animal is not an adult, then it shouldn't have 6 legs, because again, adult insects have 6 legs and no other animals have 6 legs. Therefore, we're only dealing with one type of animal here, or one type of insect. So if that one type of insect is not an adult, then you have to say it does not have 6 legs. Okay, so in this case, that would be a true statement. So again, just because we have an original is false doesn't mean all the others are going to be false. And finally, we got our contrapositive. Again, in this case, our contrapositive is going to state if not Q, then not P. Now I'm looking at, when I'm saying not Q, I'm looking at my original conclusion. It has 6 legs, but when I'm rewriting it, I'm not going to say it. I need to write it using proper English. So our contrapositive says if not Q. So if an animal, instead of it, if an animal does not have 6 legs, then I can now say it is not an adult insect. So in this case, just like before, we look for the truth value here. If an animal does not have 6 legs, so again, adult insects have 6 legs, right? So, and there's only one animal that has it. So then that animal is not an adult. Well, that's true because the adults have 6. The adults have 6 legs. But if I don't have 6 legs, I can't be an adult. So that would be true. And again, basically, you gotta know 2 things here. 3 things really. 1, you got to know what is a converse, an inverse, and a contrapositive. 2, you need to know how to rewrite those statements in actual proper grammar. And 3, we need to be able to see if they're true or not using the data that we have or the knowledge that we have at our disposal. Okay, but again, make sure you're using proper English. Do not start a statement with, like if I did the contrapositive, don't say if it does not have 6 legs. That's not proper English. You do need to state what it is. That would be an ambiguous pronoun. We don't use improper English even in math class. Alright, next up we're going to write the converse, the inverse, and the contrapositive of the conditional statement. If an animal is a cat, then it has 4 paws. So this one, we're giving you the statement. You can try to write these on your own first. I'm going to go through them rather quickly to more check your answer. Okay, so again, when you see me do this, I'm going to do it expecting that you've already tried it. Alright, so here we go. Let's do another color here. Alright, we're going to do original statement, if P then Q. Okay, we already have that written, so I'm not going to write it again. So in this case, if an animal is a cat, then it has 4 paws. That is a true statement. Cats have 4 paws. Now I'm going to do the converse. Converse is if Q then P. So if, and again here we have an animal, if an animal has 4 paws, then let's see, then it is a cat. So that should be your converse statement. But this one, there's a lot of animals that have 4 paws. Dogs have 4 paws, so this would be a false statement. Again, you can think dogs, right? That would be your counterexample. All right, so that's going to be false. Next up, we have our inverse. Inverse is not P, then not Q. So here we go. If, I'm going to say the opposite of the original statement. That's all I'm doing. If an animal is not a cat, then it does not have 4 paws. Again, I can use the same counterexample on this. Dogs. Okay, because they're saying if an animal's not a cat, it can't have 4 paws. That means nothing can have 4 paws except cats. Well, no, dogs have 4 paws, and they're not cats. So this is another false statement. Finally, we have our contrapositive. Remember, the contrapositive is if not Q, then not P. So here we go. If an animal, again, I'm looking at if Q then P up above. I'm just going to state this, and I'm just going to put not in its place. If an animal does not have 4 paws. So I'll say does not have 4 paws, then it is not a cat. So in this case, again, read it and see if it's true or not. If an animal does not have 4 paws, like it has 2, or, well, or less or more, but then it is not a cat. So if you don't have 4 paws, then you can't be a cat. So this one would actually be true. And if you don't have 4 paws, cats have 4 paws, so you're not a cat. Okay, so I know we can always be technical here. Like say, what if your cat lost a paw? But again, we're saying in general, again, cats have 4 paws. Naturally, they do, right? So in that case, it is going to be true. We don't need to always get super technical on these, but in general, these are a true statement. Okay? All right. So kind of starting to wrap things up here. We got related conditional statements that have the same truth value are called logically equivalent statements. Again, you got some vocab here we need to have. A conditional and its contrapositive are logically equivalent, and so are the converse and the inverse. So again, if we have almost basically everything as rated as true or everything rated as false, they're all going to be what's called a logically equivalent statement. Okay, so again, that's more vocab. There's a little bit of vocab in this chapter because again, we're trying to do something kind of new here dealing with logic. And again, the logical equivalence of a conditional and its contrapositive is known as the law of contrapositive. So again, these are just definitions and phrases for you. The law of contrapositive. Make sure we kind of write that one down as well. Alright, so to kind of wrap everything up here, we have a lesson quiz. So make sure you work on that in case we end up collecting it. We have our assignment we'll be working on in class. Again, for Mr. Patrick, I'll let you know what we're doing. And don't forget to do your reflection. Alright, with that, I'll let you go.